Yeah, live recording also can be started.
Hello. Good evening, PVS.
Good evening, KK sir.
Hello. Hi.
Good evening, sir. Kamalakkannan, sir. Good evening.
Good evening, sir.
Good evening, sir.
Hi.
Good evening. Can you start the video recording, madam?
Good evening, Mr. Srikumar.
Ma'am, I have initiated, ma'am, the recording.
Yeah. Yes, we got the recording sign.
Shall we start, KK sir and Dr. Sakthivel and others?
So we give a couple of minutes more, sir. So usually people have difficulty in joining. So we just give a couple of more minutes. Is that okay, Mr. Srikumar?
Sure, sir. Yeah, not a problem.
Yeah. Because they start logging in at 6, sometimes, the connectivity may be an issue. And,
Oh, okay.
Yeah. Yeah. I think we can start, Dr. Akila.
Yes, sir. We'll start, sir.
Yeah. Thank you, Dr. Sakti.
Yes, sir. So, good evening to all of you. So, we have all gathered through this virtual mode for listening the webinar on SD-WAN technology and its benefits. On this occasion, I welcome today's speaker, Mr. Srikumar S. Subramanian. He is a senior engineering director, AmZetta Technologies USA. And in this presentation, he is going to present about the SD-WAN and its benefits. SD-WAN plays a vital role in today's business community. It can bring business entities spread across multiple geographical locations under one single management umbrella and provide a secure network path between them so that all locations can work, communicate, and share information easily, securely, and effectively. SD-WAN is centrally managed and provides a single plan of network visibility. It continuously monitors network faults at various levels, including link, node, and site failure, and makes corrective action without affecting the SD-WAN network. By mixing multiple less expensive broadband connections with the MPLS connections, SD-WAN can reduce CAPEX and OPEX. It can aggregate multiple asymmetric WAN bandwidth and increase the quality of experience for the high critical application. A secure and optimal network path between branch to branch and branch to data center, SaaS and open internet is essential for enterprise and cloud-based applications. SD-WAN can achieve a better application delivery using various technologies like intelligent traffic steering and application-aware routing and SLA-based dynamic path selection. So this webinar is delivered by Mr. Srikumar S. Subramanian, and Mr. Srikumar Subramanian is an industry veteran and a computer science engineer, graduate from Tyagarajar Engineering College, Madurai, with over 25 plus years of experience in innovating and launching new products and solutions. Mr. Srikumar specializes in SAN, networking, server management, hardware and embedded solutions with over 35 plus US patents in various technologies. He pioneered the storage attached network industry at American Megatrends to introduce Store Trends product line, bringing disruptive innovations in the area of active SAN volume with the snapshot, ILM, SSD block cache technologies, advanced RAID, and HA features. Mr. Srikumar is currently engaged with AmZetta Technologies and leading the JetWAN SD-WAN product line. On this occasion, I welcome the office bearers and members of the IEEE Computer Society Chennai chapter, Computer Society of India Madras Chennai chapter, and ACM Chennai Professional chapter, and all the participants who have joined through the virtual Google Meet and YouTube network. So now I invite Mr. Srikumar Subramanian to present his presentation on SD-WAN technologies and its benefits. Over to Mr. Srikumar Subramanian, sir.
Yeah. Thank you, Dr. Sakthivel, with your kind words for welcoming me for today's webinar. Thanks to Mr. HR Mohan, Dr. Akila, Mrs. Maithili Prakash, Mr. Kamalakkannan, Mr. Subramanian, and my colleague, Mr. Chetaraman, and Mr. Santosh for giving me the opportunity to present this webinar on SD-WAN technologies and its benefits. On behalf of IEEE Computer Science Chennai chapter and AmZetta Technology, I thank you all the participants, and I take the pleasure to welcome you all for this webinar. So here is my brief profile. Currently, I am Senior Engineering Director at AmZetta Technologies, leading the Z-WAN, SD-WAN product line. Today, we will go through about why SD-WAN, SD-WAN architecture, SD-WAN goals, design choices, components, brief future review, and conclude with market research, career in SD-WAN path, end with the question and answer. Network infrastructure just using only with traditional WAN is very complex and must pay hefty infrastructure price for expensive WAN link to meet business application SLA. Expanding the business to a new branch location is time consuming. As the number of branches becomes more, the network maintenance and troubleshooting is not an easy task anymore. Firefighting over application performance becomes a daily routine. Secure connectivity across all the branches becomes complex. The pain point in traditional WAN is addressed in software-defined WAN solution, or simply called SD-WAN. SD-WAN solution offers improved bandwidth and cost effectiveness by aggregating multiple cheaper WAN links. With SD-WAN network deployment, expanding to a new branch location is just one click away. It provides single pane of management for both configuration, maintenance, as well as network troubleshooting. Application-centric network configuration is applied for traffic steering, QoS, and firewall rules. It offers inbuilt security for both branch connection and as well as open internet. Additionally, SD-WAN brings comprehensive managed service, including detailed network insights by offering live and historical network reports. It can easily scale to accommodate larger network, and at the same time be resilient to link, node, and site failures. Custom service chaining has never been easier before. With SD-WAN, it is much easier, and it is by following standard, it can be achieved. Overall, it greatly improves capital expense. It greatly reduces capital expense and operational expense for the business. It also offers MSP integration, paving the way for multiple tenants to share the management infrastructure. Business can choose any one of the three models shown here based on their size and strategy. It could be simple hub and spoke, or decentralized or completely distributed business model. The SD-WAN deployment should be able to match any of this business model. As the business expands, each and every SD-WAN component should also scale along with that. Before we talk about SD-WAN components, let us review the SD-WAN architecture. The layout depicted here is a headquarters and a few branch locations which are located across the map. The branch could be in physical location or it could be in public or private cloud. These locations are then connected with the internet using one or more of the following ISP links, such as broadband, 4G or 5G LTE, 4G LTE or 5G wireless, fiber optic cables, satellite or private MPLS link. These underlay connectivity WAN services are provided by one or more ISP providers. An SD-WAN edge device is located at each location facing the WAN link from various providers for that location. Once the edge devices are onboarded and assigned to a tenant or telecom provider, it forms a logical SD-WAN service provider through which these devices are managed. In order for the branches to talk to each other in a secure manner, SSL VPN, IPsec, or WireGuard tunnels are established between them to form the encrypted visual communication channel. Branches can still talk to open internet or SaaS application by leveraging the inbuilt security and traffic steering features of the SD-WAN. SD-WAN goals must match with the previous business goal, It must improve application performance, meet SLA requirements, provide inbuilt security in every aspect of the network communication, ability to migrate from and reuse existing infrastructure. In order to reduce CapEx, it must reduce complexity and enhance network security for network administrator to perform the task effortlessly. So, yeah, in this one, we see the SD-WAN design choices. Embracing cloud native architecture is highly recommended for wider acceptability and easy deployment. Kubernetes and Docker are highly available and distributed by nature. For any scalable deployment, cloud native architecture offers a great flexibility. Centralized management and orchestrator needs versatile identity and authorization framework. Especially for multi-tenant architecture, it needs to support both on-premise identity, database like LDAP, Active Directory, and third-party identity provider like Google, Okta, via open standard protocols like SAML, OAuth, and OpenID Connect. SD-WAN as a service facilitates multiple tenants to share the same management resources. It is an important feature for MSP and telco companies. Both built-in and third-party network management system must be supported for analytics, reporting, monitoring, and alerting. Prefer a design which allows to scale as the business grows. SD-WAN with geo-redundancy provides disaster recovery. So this all combines to make next-gen SD-WAN solution. So let's go through briefly about the SD-WAN components. So we start with internet. So we have a provisioning server. Provisioning server is responsible for zero-touch provisioning of the edge devices. It provisions and maps bunch of edge controllers to MSP. Provisioning server can be hosted in private cloud or public cloud. MSP will host the provider server. Provider server also contains SD-WAN orchestrator, and analyzer. The entire setup is horizontally scalable and it provides fault tolerance for node failure. The provider support web user interface, multi-tenant, and various authentication mechanisms like Active Directory, OpenID, etc. OpenID enables us to integrate third-party authentication server like Google, Facebook, or your own authentication server. The orchestrator component provides centralized policy, custom application definition, edge controller firmware management, and it is also responsible for, so basically the traffic steering. The analyzer takes care of all dashboard activities, all dashboard, event monitoring, alerting, and generate report on demand. In order to communicate with the edge controller, it has management tunnel server. It has management server tunnel endpoint to accept secure connection from edge controllers. Edge controller comes in various form. It could be a VM, we call it as VCPE, a physical executive hardware, or lightweight ARM-based hardware solution. Typically, VCPE runs in data center and ARM-based CPE runs in branch location. Edge controller is responsible for data plane activity and provider is responsible for control plane activity. Edge controller supports tamper-proof verified boot image. It supports multiple WAN interface of type Ethernet, LTE, etc. It supports IPsec. It supports IPsec tunnel both. It supports IPsec tunnel both AES and GCM algorithm, SSL VPN with TLS version 1.3, WireGuard, WAN link aggregation with both load balance and failover support. It supports traffic steering based on TWAMP, LTE signal quality, deep packet inspection. It also supports QoS based on flow classification. It has support for dynamic routing protocol like OSPF, BGP, multicast, etc. In security point of view, IPS, IDS, DDoS, DNS filtering, FQDN filtering is all supported within the edge controller solution. In LAN side, it supports multiple LAN subnet, VLAN tagging, and 802.380 network bonding. It communicates with provider, provisioning server and provider via secure It communicates with provisioning server and provider via secure channel. It establishes management tunnel with provider. The management tunnel is used for all control activity like device onboarding, policy configuration, IPFix data collection, and automatic firmware update. So this is our SD-WAN future overview. So today, for today's discussion, we go through this zero-touch provisioning, multi-tenant support, centralized policy, few topology configuration, analytics and reporting, traffic steering, NDPA, SAS breakout, internet breakout, IPS, IDS, and firmware update. Zero-touch provisioning and multi-tenant. And the screen is a little slow here. Okay. Okay, zero-touch secure provisioning. The SD-WAN devices coming from production. So it has the ready to ship. Basically, it has the production license applied on the SD-WAN device, edge device. So once the edge device power is connected, it contacts the provisioning server hosted in the cloud, and it is waiting for the onboarding. So in the cloud, the MSP can assign the edge controller to any one of the tenant that is of their customer. So once the configuration is done, the SD-WAN device is automatically gets the provider URL information and access key, and makes a secure connection with the provider. So once that happens, at provider, the administrator takes control and onboard that device and maps the location and other configuration details for the SD-WAN, and automatically an auto configuration takes place. So just by one click in the provider, the device becomes part of the SD-WAN network of the multi-tenant, one of the tenant group. So all the configuration applied for the edge controller via a secure management tunnel. So the management tunnel here used for onboarding policy as well as onboarding and applying policy. In turn, the edge controller uses the same management tunnel to push the IPFix and IPFix data, syslog data to the provider. So eventually later at some point, if the edge controller needs any firmware update, the same management tunnel is used. From the provider, the firmware image is pushed to the edge controller. So deploying a new branch using the SD-WAN edge device is super simple. It is just one click away. Okay, centralized policy. So here, each and every edge controller, when we onboard, it is grouped by tag. So the edge controllers are grouped by tag. The tag could be applied. It could be region based. It could be model based. It could be any custom tag. So it is applied when the edge controller is onboarded. So based on the tag, the edge controllers are grouped. For example, here we have region A, region B. So as well, each and every edge controller will have a metadata. The metadata has a default configuration, like the default, what is the default value for the time zone, subnet mask, WAN bandwidth, etc. Action template uses this EC metadata. Action template is nothing but it is a small piece of code, has list of APIs, which takes the metadata as an input and applies to the edge controller. So from the action template, we can create so many actions with the custom value. So we take the input from the edge controller and then we apply a custom value. Together we create actions. So from the single action template, let's say whether you want to create a tunnel creation, and from that action template, we can create so many actions. So it is nothing but for single action template for the tunnel creation, we can create 10 tunnels actually, just changing the value in the parameters in the action template. So we are creating 10 tunnels here. So each called as an action, but it is just ready to be applied. So once the actions are created, each and every action is put into a group. So each policy, the group is called policy. Each policy makes order list of actions. Here, for example, policy A has 3 actions, action of type 7, 3, and 9. It could be tunnel creation, and then assigning some traffic steering, and later 9 could be some of the rules applied for the allow list or block list. What is being allowed is a firewall rules. It could be ordered like this. The policy B here is comprised of 3 actions here, 3, 1, 9. 3 could be, let's say the tunnel is already created. Probably the 3 could, it's not created. It could be a WAN configuration. Then 1 is tunnel is created on top of that. The 9 could be some kind of firewall rule applied on that. The policy C could be just a firewall rule. So like this, we can have actions and the policy can be created from the action. And once the way it is put here, at the same order, the policy will be applied on the edge controller. So once the policy is applied on the edge controller, what happened in the background is in the background, we create jobs for that. So the auto policy, so when the edge controller is onboarded, we can predefine these are the actions to be applied on the auto policy. So the auto policy can be applied for a group of edge controller, or it could be on one or more edge controllers. It could be on demand, or it could be based on the auto policy. So once this happens, what happens is automatically when the device is onboarded, since it's all set predefined, so all this configuration is applied on the edge controller one by one. So eventually you will end up getting a DHCP WAN IP address and we'll be having some tunnel created on top of that. A traffic steering rule is created, and then firewall configuration is created. And you will establish a branch to DC connection or a branch to branch connection. Same thing for the open internet. There could be some few parameters set automatically on the edge controller. Same thing for the open SAS. We'll be having some parameters set there as well. It could be based on the cost. It could be based on the path affinity. It could be based on some SLA. So once that is all applied, so we'll get a nice network topology view, something like this. So here you can see there are two DCs here, two data center. So the branches are connected to the data center. Not only this, the branch can connect each other. We can have a crisscross connection between branch also. So all these things are interlinked. So the overall SD-WAN network topology can be seen in our network topology page. This is the overview version. So once we drill down to a particular edge controller, we can see that network activity for that edge controller. So we'll be seeing the list of events, and then what is the WAN bandwidth, what is the LAN bandwidth, what is the usage, and what is the individual usage for IPsec, SSL tunnel. All those things we can see one by one here in this topology view. So next item is analytics. So here, as the traffic moves between branches, so here we are seeing the traffic responsible for the edge controller. So let's say we have so many edge controllers distributed across the map. So here in a single pane of management view, you get to see the all the traffics happening in the system. And here we have chose the top application. Here we are seeing the top application listed here. So in this time frame, we can choose the time window. In this time window, we get to see what are the traffic is happening here. So we are displaying there is a display of edge controllers, and behind the edge controller, there are so many LAN PCs, and we display the LAN PC. And also we display what is the source server address, server IP address. It could be anything in public IP, or if it is something can be resolved, we will just expand this IP address basically. So here you get to see, so what is the branch location, and what is the system in the branch, and to whom it is reaching actually, and what is the bandwidth. So we get to see all the information in one page here. So like this, like a top application, we get to see what is the individual WAN interface. We can see for ingress interface or egress interface. We can choose individual WAN interface, the activity for the WAN interface, activity for the LAN interface, and also we can see any thread involved in that activity. So there are a lot of we can see the thread, we can see geolocation, we can see the application steering taking place. All can be seen in the dashboards. So here some of the demo for the activity happening in the edge controller. So here we have a IPsec tunnel created between headquarter and the branch. So the LAN is asymmetric WAN interfaces. So we have one, let's say, a 4G interface, and the other one is the MPLS. So based on the bandwidth requirement, bandwidth availability, so we have a asymmetric WAN interface, and we aggregate the WAN interface to get a better speed. And also we get a fault tolerance here. So here what happened is we have the configuration of weight 4:1. So we can see the network packets are transferred over the two tunnels in the ratio of 4:1. The first blue WAN is utilized 4 times the load of second WAN, the green. Let's assume the green is the LTE here, and blue is the MPLS. So the benefit here is load balance over asymmetric WAN interface is happening, it's taking place, and SD-WAN can control the bandwidth usage. The next one is the load balance and failover. So here we have a IPsec tunnel created between headquarter and branch. It is in load balance mode, same 4:1. Initially, the packets are transferred over both the links. And once you see one of the link is failed, let's say we have here in this case, the green link is failed. You will see the traffic for the green link is automatically moved to the blue link. The activity from the LAN PC continues without any problem. So still the activity from between the two edge controller over the tunnel, right now it's a single tunnel, is continue. So once the green link comes back, again the traffic will be redistributed on both the WAN link. Here basically 2 tunnels over the 2 WAN link. So the next thing is auto flow control based on the cost basis. So here, what we do is, let's say we have a traffic steering rule applied. We want to use the lower cost link to start with. Let's say green is the lower cost link. So all the traffic is steered through the link because the link is bandwidth is available and the link is healthy and available. So initially all the traffic get to go into via the green link, which is a cheaper link. And let's say there is a jitter or a latency randomly introduced in the green link. So the edge controller constantly monitors the link health. So at any event, if the link has any jitter or packet loss, or it has any signal quality issues, and if it affects the application SLA, then it will automatically move the traffic from the green link to the blue link. So this will automatically, even without the LAN PC notice this, the edge controller will, since it continuously monitors the link, it will automatically move the traffic from green to blue. So once the green link becomes healthier, once the edge controller finds it is healthier now, it will automatically move the packet again back to the original link, which is the green link. So by this, you can save costs. So we don't have to use the expensive blue link when the cheaper green link is available. Only in the event of any issue in the any issue in the green link, we choose to steer the packet to the blue link. Until then, it will continue working on the green link. So this one is the SAS internet breakout demo. So this one we have a path affinity. So here, if you see, so we want to have the SAS link, SAS traffic wants to be sent via the green link, and the open internet traffic we want to send via the blue link. So the reason could be maybe the green link, we feel it could be it has a better performance. It could be more reliable. So we don't want to have our SAS packet to be. It is meant for the high productivity. So we don't want to be disturbed. So it needs a better SLA. So we choose to steer the green packets, the green traffic, which is for the SAS via the green link, and the open internet traffic via the blue link. So let's say the green link fails. So here what happened is, now the SAS has the affinity to the green. So even since it has affinity, initially it was flowing through the green link, right? So if in the event of the failure of the green link, it will still again continue with whatever available link in the system actually. So here we have a blue link available. So it will continue using the blue link for the SAS connection. So once the link comes back, since it has affinity to the green link, it will automatically move to the green link without any intervention from the user. So SD-WAN will continuously monitors, as we saw earlier, it monitors for packet loss, jitter, links. So based on what is configured, based on the cost advantage and many parameters, it can make the steering automatically and make sure that the traffic moves from the LAN PC to the branch or to the open internet or to the SAS without any problem. So here about the illustration about the IPS and IDS, intrusion detection and intrusion prevention. Here the LAN PC make requests to SAS application and open internet. Responses are coming to LAN PC. Responses include traffic from SAS, open internet, and some undesired packets too. IPS, IDS, which is inbuilt in the edge controller, monitors the incoming WAN traffic and actively filters spyware, trojans, ransomware, phishing, malware, worms, and other inappropriate packet, and thus protects the system in LAN subnet. Information about such filtered packets are sent to ELK for further review. So it's sent to the analytics or network monitoring system for further review. Subsequently, alert will be generated for administrator attention. So if you see here, all the red traffic, the red packets, which is coming from the malware or the Trojan, are being continuously monitored by our IPS IDS module, and it is dropped even before further processing or without any forward to the LAN subnet. It drops and then it makes a note, it sends alerts to the PILC. So here we are seeing the firmware update. So it is one of the feature comes with the multi-tenant. So what happened is, so we have so many CPEs. So we have MSP have a couple of CPEs here. So we don't have to do a constant monitoring of the firmware update or anything. If as and when the firmware is available, we want to have everything automated. We want to have our firmware pushed to the edge controller. So here what happened is, from the SD-WAN provider, so the firmware is verified and it is pushed to the some location where the provider can has access to. So here, so it could be a S3 bucket or it could be HTTPS. The firmware is pushed there, it is verified and signed. So once the MSP sees the firmware is available, it can make a manifest file. It can tell what is the target firmware, what is the from which firmware we want to update for the to move to the which target version actually. So any edge controller belongs to the version from the from location. Anything it matches to that firmware version, it will automatically move to the target version, which is available in the S3 bucket or HTTPS location. So here what happens is, once the firmware is moved to the online S3 bucket, the provider is informed about the firmware update. So provider creates a manifest and the manifest is given to the orchestrator. Now the orchestrator sees the version mismatch in the edge controller. So it informs the edge controller, yes, so we have a firmware available. So you take care of updating the firmware by yourself. So the edge controller comes, checks for the new firmware, make sure that it is really a compatibility, the firmware is compatible and it has to be applied. If that is the case, it downloads the patch, or it could be a full update. It downloads, verifies the image, it updates itself. So once updated, the firmware, the image, the version of the CPE automatically moves to the one level up to the target version. So here, so we don't have to go to edge controller and do any activity manually. It's all happening from the one single place, which is the orchestrator or the provider. Once it is all happening, it is up to date, and there will be a event or notification sent to the administrator. So like this, any activity that we want to do in the CPE can be done centrally via the provider, the orchestrator. So it could be a configuration, it could be on-demand policy, it could be an auto policy, it could be a firmware update. Anything that we want to do from one single location, all can be done from the orchestrator or the provider itself. So since each tenant has its own access to the provider, they get to log into using their credential, they get to log into the provider. They can control the CPEs assigned for that tenant actually. So here MSP gets a global view. MSP takes care of the global items, like the bigger items, like a firmware, like any patch update, right? Certificates, all the bigger items are controlled by the MSP. So underneath, all the tenant, based on their requirement and based on their demand, they get to choose what to be taken, what to be ignored, how to be configured, what to be applied. So what we do is the policies and all is tenant specific. So we keep at a tenant level. So these, as you see, we saw both update as well as policy. So the policy based on the tenant requirement, how it is configured, how the CP is distributed, it get to choose the action template and policies and apply those on the CPE or group of CPE. So as you see, both the policy as well as the update and other IP fix and other analytics happening at one single from one single location, which is the provider. I think you have to mute. Yeah, thank you. So here we are looking for the SD-WAN market adoption and its growth. The chart depicts the adoption rate of SD-WAN for last 5 to 7 years. it can be seen clearly that telco and IMSP have embraced SD-WAN technologies, particularly in APAC, the Asia Pacific. SD-WAN is identified as a fast-growing market with the projected market size of $43 billion by the end of year 2030. So we see a lot of opportunity for SD-WAN in India. So and we see even in this webinar, we see participants mostly from in this industry, the telco and the MSP, and we see a lot of students as well interested in the SD-WAN technologies. So for them, for the engineers who want to pursue a career path in SD-WAN, the certification shown here is highly recommended. Any Linux certification, network certification, and a cloud certification is a good starting point. For orchestration side, certification in the Kubernetes track can be pursued as well. So here, we conclude the SD-WAN technology and its benefits. So we have briefly gone through the architecture, the goals, and the components. And we also saw how we can apply the auto policy or a centralized policy via on-demand as well as while onboarding. And we briefly went through various traffic steering implementation, like when the link failed, what happened? When the packet latency is introduced in the WAN link, what happens to the packet? We also saw what happens for the malwares coming from the open internet, how the SD-WAN, the inbuilt security system protects, filters, drops those packets, and gives notification to the administrator. Then for example, we saw how the provider from single point, we can manage so many CPEs and how it is all grouped under the tenant. So we quickly just saw the brief overview of the firmware update. So this is all based on what is expected in a SD-WAN solution. So on top of that, we also have advanced features like a HA, high availability. What happens if the site fails? What happens if the node fails, right? So all those things must be monitored by the SD-WAN solution, and it should take an immediate action automatically. So the node failure is an automatic process. When the node fails, it will automatically move to the next node. If the site fails, if the entire site, let's say a data center fails, then it is a controlled manner. We have to move the application servers to the DR location, and then we spin up the SD-WAN solution in the DR location. So when you look for a SD-WAN solution, we have to make sure that all these checklists are addressed in the solution, so that for the administrator, the management and configuration will be effortless. Yeah. So by this, I conclude this presentation. So if you have any question and answer, I'll be happy to take those questions now.
Thank you very much, sir, for your informative talk on SD-WAN technologies and its benefits. So we have received a few questions from the registered participants. So I will read one by one and can give the answers. How data is secured in SD-WAN technologies that prevents from hackers?
Yeah. So in SD-WAN, so what we're doing here is we have, as soon as it is a two-way protection basically. So first thing is, once the SD-WAN is configured with the WAN interface, so we identify the list of interface is meant for WAN. So we immediately update two items there. So one is the DDoS, the other one is IPS and IDS. So any packet coming via the WAN interface, ingress to the WAN interface, it first goes through the DDS and the IPS and IDS. So here what happened is, so any repeated hacking, let's say it is a TCP flood or a sync, ICMP flood or a TCP sync attack, right? So that will be happening, TCP sync from same source IP. Let's say you make thousands of TCP connections. So the DDoS will detect that. And if it finds that it is all happening from the same source, and it is not a it is not a normal behavior. So it identifies that, it drops the packet for the duration of period, so that further attack cannot happen to the SD-WAN. So while it does, it makes that report to the provider so that administrator will be alerted on that. So administrator can review the attack and see whether it is a valid one, legitimate, or it is a false positive. So based on that, you can make a decision on the you can make a decision and reconfigure the SD-WAN solution if need be. So most of the case, if it is an attack, then the packet is not allowed further to the LAN subnet. It is dropped at the SD-WAN edge controller itself. Same thing as we saw in the IPS and IDS, each and every packet is actively monitored, and all the traffic will be dropped in the edge controller itself. And one more extension here is, let's say the branch is a ARM solution where we cannot run IPS and IDS because IPS IDS demands CPU cycle as well as it demands quite amount of memory basically. So let's say the branch is a very low cost solution and where we cannot afford a IPS IDS in the branch location. The solution is, what we can do here is all the open internet traffic, instead of branch making an internet breakout, you can send that open internet traffic via the secure tunnel to the data center and the headquarter. So from the data center and headquarter, it can collect all the open internet traffic from the branch, and then it will on behalf of the branch, it can make a open internet traffic. It can make an internet breakout. So once that happens, as a response comes to the DC, because DC is the one which did the initiate the traffic on behalf of the branch. When the response comes, DC is much powerful system where we have a IPS IDS running. It can be monitored there on behalf of the DC or on behalf of the branch. It will monitor. If it is any problem, if it is a malware or it is an attack, it can be dropped there, and the event will be generated for the administrator. And only the legitimate packets, only the valid packets will be sent back to the branch. So by doing that, even a edge device with the which is not capable enough to do IPS and IDS, it can use the help of DC data center or the headquarter, and all the filtering and scanning done at the powerful site, and it get the protected packet. Get the filtered packet to the branch. So thus the branch can protect the LAN PCs. So we support both the branch directly doing IPS IDS, or it can get help from DC due to the IPS IDS. So thus by having this, right, so we can protect this, the hacker cannot easily come to the branch location, or they cannot come to the DC. And same thing, we offer the service chaining. So we can have the, if you have any third party antivirus or anything like that. So if you want to chain with the VCPE, so we can do that actually. So that services can be chained in the VCPE. So you can hop through multiple services, custom services. So further filtration, further protection, further scanning can be done. So this can happen at the DC side. So this is how it's not easy for the hacker to come to SD-WAN solution, because it is not an afterthought. For each and every packet, ingress packet coming from the WAN, it is always actively filtered and monitored. So only this filtered one goes to the LAN PC. Same thing on the LAN PC side, we have a protection like VLAN. We have some of the isolations are there, the physical isolations, so that if even let's say you have a guest network in the LAN side, right? So we don't want that guest network from the LAN side coming to the corporate network. So we can have as isolate those traffic as a VLAN. If need be, we can apply some of the firewall rule in the LAN side so that the guests coming from the LAN interface in the branch, they cannot come to the corporate network. So both sides, the protection is enabled from the edge controller. Yeah.
Thank you. The next question is, what are the differences between VPN and the SD-WAN?
Yeah. So VPN is just a secure connection from one end to other end, but it does not offer anything more than that. It doesn't offer traffic steering. It doesn't about any information about the siblings. There could be one or more VPN. A single VPN doesn't understand anything about the siblings. It only knows about that particular tunnel connection. It does the encryption. It does the compression. It could be based on the PSK based or a certificate based. It offers a full encryption. So man in the middle cannot happen in that tunnel basically. That is a good news. But the bad news is it does not understand the siblings. It doesn't understand. It doesn't take care of any packet loss or any latency introduced in the tunnel. So one side above, it has no information actually. So that is where SD-WAN comes. It aggregates one or more such VPN tunnels. So it knows each and every VPN tunnel capability, each and every VPN tunnel health. So based on this, it can do a traffic steering. It can use multiple VPN tunnel, perform a traffic steering. It can perform quality of service. It can make a very decent application SLA by using one of these tunnel. So by actively monitoring these tunnels that is in hand, it can make a educated decision for this particular application, for this particular network traffic. What is the best tunnel to be used for? So that is something only SD-WAN can do. SD-WAN uses the VPN to make the decision, but VPN by itself doesn't do that. It doesn't have that intelligence basically. So that's where the VPN and SD-WAN differs.
Thank you, sir. The next question is, what are all the usage of SD-WAN in telecom domain?
So here, like even for telecom or MSP, if you see, so as we saw earlier, starting a new location is very difficult actually, because so we have to telecom. We have to migrate from the existing infrastructure to the SD-WAN. So we don't want to abandon everything what is there in the business by doing adding a new location or accepting a new ISP or migrating anything like that. So there are two advantages. One is a fast deployment. Another one is you can keep adding more lines to the branch location. Let's say the telecom has two different WAN links of different characteristics, right? So the telco can easily bring this two WAN interface to the branch location. So one is, it lets the SD-WAN to take care of which is best for the user. So that can happen. The second thing is, it allows the business just to grow just by dropping a edge device into the branch location and performing an auto policy configuration. So telco, right from that, and for as all the activity happening in the edge controller is constantly reported to the provider. So provider get to see in single plane what is the bandwidth on each WAN interface, right? What is the SLA for the WAN interface? When it was down, when it was up, all the statistics are available in the provider. So telco can take this information. It can be used for telco billing. It can be used to give a better experience to the customer. If he sees so many WAN interface, he can go and take a look of these issues, latencies, drop, all those things they can watch, and they can give a remedy. So another advantage here is, even one WAN link has a problem, the telco has a potential to make use of the SD-WAN to steer the traffic to the different WAN link.
Thank you, sir. These are all some of the questions from our participants.
Hello.
I invite our chairman of CSI, Computer Society of India, Chennai chapter, Mr. P.V. Kamalakkannan, to formally propose the vote of thanks.
Hello. One question.
Yeah, yes, sir.
One small question.
Yes, sir. Yes, sir. Please, sir.
The IoT and SD-WAN, these two technologies, I think, can be combined. What is the kind of future you have for this combination of IoT and SD-WAN?
Basically, if you see that our design choices, the Kubernetes, Docker container, and the way the microservices, those are all high available, and it can be distributed across multiple nodes. So the IoT puts a lot of information to the central location. So there is a lot of data processing involved. It is very similar in the SD-WAN. In that aspect, is very similar to the SD-WAN. So the underlying orchestration side, so let it be IoT or SD-WAN edge device, right? The incoming data and the way that we have to process. So some of the data we have to process in memory actually. So we cannot just store in disk and then process later. So it has to be processed in line basically as the data comes. Because in IoT, the decision has to be made. As the data comes, we have to make a decision there actually. So it is instantaneous. Similar thing, right? If you see in SD-WAN, the same thing happened here as well actually. As the data comes here, most of the decisions are made instantaneous basically. So IoT is like in even much, if in terms of number of nodes, n nodes, it is magnitude of more than SD-WAN. But the overall orchestration part, if you see, so the SD-WAN, we take most of the design choices, the tool factor application rule. So we take it from those what is common for the SD-WAN IoT, and by implementing that in the SD-WAN solution, so what happened is the SD-WAN solution only becomes robust actually. It is more common. The difference is here the IoT is if you see that packet information IoT is only in kilobytes or bytes actually, but SD-WAN it's a network packet. It's a full network size packet. It's full MTU size packet. So it is, the tunnel is a very important item here. So the experience is very important. The application experience is very important. So these are the area it will differ actually.
I'm not talking about the difference. I'm only talking about how to combine this, because IoT is also growing area, and SD-WAN is highly secure and all that. From the security point of view, and SD-WAN will be a kind of complementary technology to IoT. From
That's
that
correct.
point of
Yes.
view, because people are
Yes.
thinking about this, I just wanted to share my thought with you so that you can enlighten.
Sure. Yeah. So mainly that is the reason, right? Moving forward, now we see for security reason, for lightweight security tunnel. So we have on top of HTTPS, we can send packet via HTTPS to the data center or the headquarter for processing, or we can use WireGuard. WireGuard is very lightweight, and device is capable of running WireGuard that can be used, or you can just have a piece by piece information sent via HTTPS. Once it comes to DC, because the IoT device is not going to have a lot of processing power, it is not going to have a multiple WAN interfaces. It is not going to have actually. So if a device fails, the next device will take care automatically. Entirely a different device will take care in terms of IoT. Unlike in SD-WAN, where the single device will handle the multiple WAN interface. So here the common item, right? Like a lot of things that we do in SD-WAN, like the central processing, and for example, the one that we discussed, the IPS and IDS, which is happening at one single place at DC on behalf of a branch. This is something can be very well applied for the IoT as well. So the technologies, those are the technologies that we applied on the SD-WAN can be easily brought to the IoT world as well.
I got two questions for you. Number one, how robust is cybersecurity in the SD-WAN environment? And number two, the minimum configuration, will you need 4G or 5G in this particular case?
Could you please repeat your first question? There was a noise there. Could you please repeat your first question?
How robust is the cybersecurity in the SD-WAN vis-a-vis its predecessor? Yeah.
Okay. Yeah. See, in SD-WAN, right, the components that is used is very up to date actually. So it is constantly being updated by the provider from the central location. As soon as the provider get to see, for example, for the IPS and IDS, the rules are getting added every day. So as soon as the day, we call it as day 0. So once we have the subscription to the day 0 subscription, the IDS IPS rules will come to the provider as soon as it is available, and the provider get to push those rules to the SD-WAN immediately. So that's what we saw the firmware patch update. So that is the same mechanism we do for the rules as well. So from the central location, we can push the rule. Vice versa, the branch can be configured to pull the rule from the any third-party database as well, like a SNOT or Suriketa. So anything happens there, anything that we identify so in the open internet, right? Any vulnerability comes in place, is noticed. Once the moment the rule is created for those, that can be pulled to the SD device immediately. So here what happened is, right, like unlike since it is geared towards that, so those update for the rules or the any for example, let's say we have a service chaining where we have an antivirus, right? So the antivirus has a day 0 attack remedy then that can be pushed to the service chaining module. So there, as we process the packet, right? So since all are updated as and when the solution is available, so it is highly protected basically. Like we don't have to, administrator doesn't have to do anything additionally in order to keep the system up and up to date. So by nature, by design, so it is set to get the latest as soon as we have a subscriber, we have a vendor providing the rule or the signature for the virus, anything like that to be scanned. So since it is equipped for that, so it is very hard to hack the SD-WAN device. It is hard to hack that system behind the SD-WAN device. And that's the reason, like a ransomware, this is a cyber security. When we talk about cyber security, ransomware, phishing, these are the items which bother a lot to the end user. So we have a thorough analysis of the those such packets via the IPS rules actually.
My second question was about
Yeah.
the environment. Do you need 4G or 5G for this?
Yeah. So here, so if you see, the SD-WAN device is capable of running from just few megabytes to hundreds of megabytes actually. So there is no, it supports a wide range of bandwidth. It supports 4G or 5G. It also supports MPLS link or a fiber optics link. So there is no bottom or high end. As long as the hardware support, the architecture supports these. If you have a hardware have a powerful enough to process the packets, right? There is no limit or upper limit or lower limit on the interface. So since the if in remote location, right, where we do not have a facility to have a fiber optics or MPLS, where we want to end up using a 4G, right, in the remote location to, or let's say it's a village location where still is developing, right? You have only 4G for now, right? Still, this device can be put there. Multiple 4G and device SD-WAN edge controller with the multiple 4G can be kept there, right? And still we can do a traffic steering, load aggregation, and then failover. All those things can happen there as well. So there is no limit. It supports any physical medium actually.
Thank you so much.
Okay.
Thank you very much, sir. Over to Kamalakkannan, sir.
Yeah, once again, thank you for all event coordinators and the participants. I had a small hiccup in between in my laptop. Sorry about that. For any further question, please reach out us via phone call or email. We'll be more than happy to take your questions. Thank you.
Hello. This is KK Kamalakkannan, chairperson of CSI Chennai chapter. Thank you, Mr. Srikumar, so much for handling the webinar today. I think today we had a wonderful session, very technologically intensive subject, very treated very well, and most lucidly explained even the intricate concepts in a way people can understand. I still remember long back when I was in TCS, when we used to set up the delivery centers, it used to be a huge infrastructure exercise because we had to lay the cables, we had to provide the connectivity, we had to provide security, connect it to the proper modules, and by the time we set up a secure WAN, secure network for the customer, it will take a few months or at least a month. But then once SD-WAN came into picture, I think it was absolutely a cakewalk. No longer we were constrained by the physical limitations. Like if the customer wanted to expand the center from, let's say, 100 seats to 200 or 100 to 150, it was just a matter of a few days because we could easily define it by software. So SD-WAN, in fact, is a phenomenal invention, and that has really brought down the cost so much, and it has given us a flexibility, which is what Mr. Srikumar so nicely explained. How SD-WAN can really collaborate with all the technologies that are available without infringing any one of them. At the same time, giving the equal or similar quality of services and similar security provisions. So thank you, Mr. Srikumar. And I would also like to thank the participants. I think there were all these participants, even though the attendance was, I would say, slightly thinner than the other webinars, but I think it is all the entire audience was technologically interested, and they were very keen, technically sound, and that was proved by the thought-provoking questions that came from the audience. So I'd like to thank all of them to have participated so intensely in this webinar and asking suitable questions. And thank you, Mr. Srikumar. You fielded all the questions very nicely, and went deeper into the question and very nicely resolved all the queries that we had. So I'd like to thank you, Mr. Srikumar of AmZetta Technologies, to have come here and talk to amidst us. And I would like to thank Computer Society of India organizers and the ACM members and the IEEE members who have joined in spite of this being the weekend, and all the organizations who supported us. So thank you all very much. And I'm sure, Mr. Srikumar, this is not the end of the road for us. I think we'll be in touch. We will have a lot of scope for collaboration together. This year, Computer Society of India, Chennai chapter, ACM and IEEE, we would like to have more and more seminars, more and more conferences this year. So I'm sure there will be opportunities for us to collaborate. So we'll be in touch with each other. So once again, thank you all for joining us today.
Thank you,
Thank
sir.
you.
Thank
Bye.
you very much.
Thank you, sir. Thank you.
Thank you so much. Thank you.
Thank you all. Bye.
Thank you, Dr. Srikumar.
Thank you, sir.
Thank you, sir. Thank you, India team. Thank you, India